Let's continue. Let's go to page 24, where we're actually going to solve a problem. So exercise 2 on page 24. A population of llamas on a tropical island can be modeled by the equation, and it got a little funky here in our packet when it got printed, so just write down this equation. P equals 500 times E to the 0.035 t power, where t represents the number of years since llamas were first introduced to the island. How many llamas were initially introduced at t equals 0? Now, this is an important concept that you really should already know, but anytime we're talking about an initial value, remember that's really our y-intercept. That does mean when x equals 0, or in this case, t equals 0, since t is the independent variable we're using here. Now, of course, there are ways to do this on your calculator, but you are being asked to show the calculation, so show your work. Initial value, y-intercept, those all mean plug in 0. So what we would do here is just 500 times e, 0.035, and then instead of t, we're plugging in a 0. Okay, you could now just type this whole thing in your calculator. Okay, or we could simplify piece by piece. 0.035 times 0, right? Anything times 0 is just 0, right? And then anything raised to the 0 power is 1. So this becomes 500 times 1, which is just 500 llamas. Okay, so you could also have done that on your calculator by putting the equation into y equals and just looking at x equals 0 in your table. Okay, but again, they wanted the work, so here's the work. Now, that's all review. Here's the new part. Let's algebraically determine the number of years for this population of llamas to reach 600. So we're going to take our equation and set it equal. We want to know, when does this population, which is the other side of our equation, right, equal 600. Now, just like we would if this were a regular exponential or log function, the first step is to isolate the special piece. In this case, the base e. That's our exponential. So isolate the exponential, or I'm going to write step 1, isolate base e. Okay, so that base e with its exponent, we need to get it alone. Well, currently it is being multiplied by a coefficient of 500. So let's divide to get that out of here. That leaves me with just e to the 0.035 t power equals, now 600 over 500. Use your calculator, guys. Don't just guess. So let's pull this up. 600 over 500. 1.2. If you'd like to use it as a fraction, you can do that as well. Totally fine. But I think most of us prefer decimals at this point. Okay, and just like we've been doing with other exponential and log functions, once we have that base isolated, now we need to perform the inverse. On a regular exponential, the inverse would be the log, but for an e, the inverse is the ln, the natural log. So instead of log, I'm writing ln. You don't have to write base e, it's just assumed when we're using the natural log that the base is e. But we're doing the ln of 1.2. Come back around for our equals, and it equals this whole exponent. Okay. Now that our exponent, our variable, was brought down to the real world, it's no longer stuck up there in our exponent. Now we can do our last step, which is to solve for our missing variable, which in this case is t. So we are going to divide by 0.035. Okay, and that is going to finally bring us to just t all by itself. All right, and now in your calculator, you are going to evaluate this all at the same time. So we're actually going to use this ln button, ln of 1.2, close your parentheses, over 0.035. Remember, we do not want to evaluate this too early. We're just doing all of our evaluating and rounding in one last step here. So put this in, 5.209. We are asked to round to the nearest tenth. So this would be 5.2 years until this llama population would reach 600. Okay. Now let me get out of this calculator and get back to our problem. So we just went over a review of how to find y-intercept, which should be totally fine for you guys by now, and solving a problem with e using the natural log. Okay, so e is just a special exponential base, and ln is just a special log. They are buddies, they are inverses, they go together. Okay, now I want you guys, for your official homework, page 25, now that you've learned the lesson, I want you to try on page 25, 1, 3, and 7. 1 is review, it's finding the y-intercept. Okay, it's a multiple choice, so don't worry about doing it algebraically. You can use your calculator. 3, do what we just did, right? First, isolate the base here. So there's your first step. Then do your loop. And they're actually not asking you to solve it completely. They're just asking you which one of these would be like your final answer right before you evaluate it in your calculator. And the last one, and technically this should be a number 5, but there's a typo here, word problem. Just like our llama problem. So set it equal to what they're telling you to, and try your best to solve this, just like we did with the llama problem. So if you do need to go back and watch the llama video again, go ahead and do that. Okay, I am going to ask you guys to put your answers for 1 and 3 in, and then number 7, some lucky person will be chosen by stick pick to present it on the board tomorrow. All right, I hope this wasn't too bad. Thank you so much, guys. I will see you tomorrow. Remember that tomorrow is also our Christmas decorating party if you want to stay after school and help us. Not just Christmas, any holiday. If you have any extra holiday decor you want to bring in for your own,